Hi, my name is Lance Finney. I'm an Angular developer and consultant with Oasis Digital, a division of Valiantis, and an instructor with Angular Bootcamp. I'm here to talk about signals in NgRx, specifically selectSignal and signalStore, some changes that have happened this year. And I'm really interested in these because I've been using NgRx for about 7 years now, and I'm also the creator and maintainer of the NgRx curriculum that Angular Bootcamp teaches. So I've spent some time looking at how these things work and how they change our code, and I thought I'd share with you some of the things that I have discovered about how it looks in our Angular applications to use these new tools. So there are 3 different APIs that were generated this year by the NgRx team for dealing with signals. The first one was selectSignal, which is a really small change that came out in version 16, right when Angular released the initial developer preview of signals. You can see the link to the RFC there to see more discussion about it. Bigger changes came with version 17, right after Angular's version 17 in November, with signalState and signalStore, which are huge new APIs, really new ways of dealing with these things. And I'm going to go into more detail about those. I'm actually not going to go into much detail, or any detail at all, on signalState. It's a subset of signalStore. So by focusing on signalStore, you'll see all of the main ideas that signalState uses. So to look at selectSignal, I'm going to show you this application that we use a lot in the Angular Bootcamp curriculum. It's a simple to-do app with some fake to-do items. Some of them are from work, and some of them are from home. So we have completed filing paperwork and sending emails, but still need to do update task list and work on project B for work, etc. And I can mark update task list as being done, but oh no, I have some more emails to send, and I really have more laundry that I need to do. That sort of thing. And I can click complete all. That moves everything from in progress to done. It's a pretty simple app with fake data, but it is really useful for us in Angular Bootcamp of teaching concepts around component reuse and RxJS and NgRx. So let's see what it looks like to use selectSignal on this. Here you have a comparison of a component in 2 different versions. On the left, we have this component as it's done when we are done teaching our basic NgRx effects step. And on the right, you see it adapted for selectSignal. And there's not much difference. So on the left, we do, as we normally do with a store, of use the select method, passing in a selector to get an observable of whatever it has, in this case, a string array. Once we have that, it is available for our template to use the async pipe to get that value out, to do the subscribe, get the value out, and the automatic unsubscription for us. The new approach on the right is almost the same. The only difference is instead of saying select, there's a new method called selectSignal. And instead of returning an observable, it returns, well, a signal, as you might expect. Now that we have our signal, we can make use of it in the template by using the parentheses instead of the async pipe. And otherwise, it's pretty much the same. Both are safe in terms of subscriptions because signals don't really have them. Async pipe takes care of the unsubscription for us. Both will get any new values as they are changed in the store and put them on the screen. It was a very small change, but a useful change for us as developers to be able to start using signals for better change detection while using NgRx. The bigger change is what's going to come with the signalStore. So to talk about signalStore, I want to do a little review of the redux flux pattern that NgRx uses. So again, for anyone who has dealt with NgRx before, you're probably familiar with this, but it has a central store that is the single source of truth, and a component can get information out of that by using a selector, either select or selectSignal, to use that selector to get the value out. When something happens in that component to change our state, we will dispatch an action, and that action will be handled by every reducer and every effect in our system. The effect might look at that particular action and make a call to the backend or something like that, and then dispatch a new action with more information. So maybe a load information action, and then a load information success when the information is loaded. That would then go to the reducer. And all of the reducers will pay attention to all the actions, and some of them will say, this is something I care about, and take the old state and that new action payload and put them together into a new state that represents what it should be and give that to the store. So that is the pattern that we are used to with NgRx. And signalStore isn't using that pattern. It's really interesting that it's not. It's a completely new approach. A lot of the things that have been added to NgRx over the years, like entity and data, were building on what was already there. And this isn't. At least not as far as the users have seen. Perhaps the internals are building on it. I don't know the internals that well. But in terms of adding new concepts, this is a brand new concept. It is not a tweak on the existing concept. It is not an additional API that you would use in coordination with what was already there, except for one small thing I'll talk about later. It's a new way of doing things. So, it's very interesting. Let's take a look at what that means in practice. So, now I'm going to compare that selectSignal version with the signalStoreified version of the exact same application. And you can see that a lot of files go away. Now, I looked at the work task component before. Let's start with that. Most of the changes here are actually not really related to this. I just started using function-based injection instead of constructor-based injection. And it really doesn't matter. That is not part of the signalStore. Both sides could use either form of injection, and that would be the same. But really what happens in both cases is we use dependency injection to get something out of NgRx and then get two signals out. But the way that part is done is different. With selectSignal, based on traditional NgRx, as I said before, we will call selectSignal and pass in a selector to get the signal out. The new way, well, we get that store, and then we just have access to the signals directly. It's a lot easier mental model. This component doesn't really know at all that it's dealing with NgRx. As far as it can tell, work task store is just a service. And done work and to-do work are just properties that are signals on that service. It doesn't have to do anything special. There's no extra concept like a selector and a select method. So that's kind of interesting. The other part of it is also simpler. In traditional Redux-based NgRx, to dispatch an action, we dispatch an action onto the store, wrapping the payload that we want in an object so it has those values. Now, we are simply calling a method on the service, passing in the values that the method needs. Again, as far as this component is aware, it's just using a service. It doesn't have any extra concepts. So for your component authors, this is going to be a lot easier. So how did we gain that? Well, we were able to change things. Instead of having these various concepts, there's one spot that has everything. Now, there might be a cost there. You might decide that having everything in one spot is too complicated, but I want you to take a look at it first. Other things that changed, we don't need to register our reducers. Previously we would register them in our main.ts or even older in app module, setting up that we have our reducers and our effects and all of that registered, and all of that's gone. It's just using a service. So we're able to get rid of some of these files. These are all just kind of setting things up. But what this new work task state is really a combination of the effects and the state together. And this already is as it was, simply because this is a small enough example that the actions and reducers and selectors are all in one file. If you have a large application at all, you probably have them broken out. But in this particular case, it was small enough that we didn't bother. But in the old way, we had our actions, a group of actions that were defined for this slice of state. We had our interface, and that part didn't change at all. You can see that it's the same interface in our state. We had an initial state, And this could have been inlined down here. I did inline it in the new version, so that's not really a difference between the two. But then we also had our reducers. The reducers are gone, or at least changed. And we have our selectors. And the reducers, as you probably know if you've worked with NgRx before, would take the old state and the action and then return a new state that corresponds to that action having occurred. Each of these would get every single action that came through. So set work task, this bit of code would respond when the action is set work task, but it would also have a chance to do complete all success and load work task success. It would just ignore those. So all of the actions would go through all of the reducers, but when it mattered, it would get into that reducer, take the state, take the action and its payload, and then return some new calculated state from it. In this case, it's something that comes from this pure function below. In this case, complete all means take everything from the done work and everything from the to-do work, put them into done work, and remove everything from to-do work. In the case of loading them, well, we just load in our initial values and that replaces the old state. That's what we did before. What we do now is quite a bit different. So now, with the new approach, and when I say now, you can still use the old approach. It's not going away. It's not gone. It's not obsolete or deprecated or anything. It's just the way I phrase things. With the newer approach, we have this work task store. And this is a service, as we saw in the component. But it's a service that's defined differently than I usually define services. Usually when I see services, they're a class with an injectable decorator where we define provided en route. This is also a service, but it is the result of a function call. We still have provided en route, but that's part of the arguments to that function call. So this is still generating a service for us for dependency injection purposes, but it's structured very differently than most of the services that we see in Angular. What do we do in here once we have said that we're providing an en route? Well, first, we say what the shape is of our state. So we're going to say that this store has state that is of the shape of this array up, or this interface up here. And once we've done that, we also give it our initial value. And these two have to match. If they don't, it's a compile time error. Once we've done that, it automatically creates for us some basic selectors, essentially. These selectors that are down here, these are basic selectors that we're just getting the state out, and it's doing some possibly unnecessary defensive coding of making some copies of here. And I know that if we were using the more modern create feature, we wouldn't even need that. Those selectors would be automatically generated for us. But for instructional purposes, we don't use that more advanced approach with this version of the code. So we don't have it here, but we do get it for free without even having to think about it with signalStore. We've defined that there are properties on here called done work and to do work. So our state has properties called done work and to do work, just automatically. And that is what our component used when we looked at it before. The interesting thing, though, is done work and to do work are defined up here as arrays, but they're part of the state as a signal of array. So it's a wrapper to the signal automatically. So we don't have to use a selector or select signal. It's just every time we access them, they are already in that approach. They are properties already defined on the service for us as signals. Now, we could add more complicated selectors. What if we needed a selector that gave us the total number of tasks, both combined of to-do and done work? If we wanted to do that, we absolutely could with another approach here called with computed. And with computed would take the state and would return an object that would have a signal called total, which would be defined by computed. I'll need to import some of these things. And with computed, this is one of the new primitives that came with signals in NgRx 16. now that we have our computed, we can return state.toDoWork, get the value out of it, .length, plus state.doneWork, .length. And now that we've done that, we have created essentially a new selector, and this total is available to our components for us for free. Interestingly, it's not just available in the components, it's also available at other parts of this definition. So below this with computed and this with state, anything that's defined there is available in all of the other configuration methods below. So the next one is with methods, and I'll tell in a moment what that is. But with methods gets that state, and it has done work and to do work in here. And because I just created total, it would also have total if I wanted it. So that's kind of interesting how these work together and build together. And you can create these, accumulate them as you go through the configuration. So with state, defined the state of those two things, and then it gave us the signals below, and we come here with methods. What does with methods do? It's essentially the combination of our reducer and our effect. So we had our reducer over here to set work task and complete all success and load work success. I didn't actually look at it, but over here in the effect, we had an effect that NgRx on init effects as a lifecycle hook to say load the work tasks at the beginning. Then we will listen to all the actions, narrow it down to the load work tasks, switch map on that, make a call to a service to get the values from the server, pipe on that to get them in the shape we want, and dispatch a success when we're done or a failure if there's a problem. And to handle that failure, we have a different effect that listens just to that failure and does some console logging, etc. So that, plus everything in these work tasks, is essentially done for us in with methods. So the set work state, that's just the reducer. That's defined over here. Previously, we would be listening to a particular action and then grabbing the state and the action and doing something with some call to return to the store. We essentially do the same, but it's organized differently. We now are creating a method that will exist on this service that will take as arguments the task and the complete. The same properties that were on this payload before. Once it has those, we will make a call out to our pure function. Had to organize things slightly differently. Instead of passing in the whole state, pass in the results of the signals, but it doesn't really matter. Pass those in, get the new value, which is a subset or the complete set of the overall state, and then patch that onto the state that we already have there using the patch state method that came from NgRx signalStore. So anytime set work state is called, it passes in these two arguments. We will recalculate the state and patch it onto the store. It's pretty much the same thing that the reducer was doing before, but instead of dispatching an action to get it, we're just calling a method. Same thing with complete all. When complete all success action came in, it had the old done and to do as the properties. We're not passing those in, we're getting those from the state. We have our done work and our to do work that we got up here through destructuring, and we can patch state with our new state that's there. The more interesting one is load. This is where we used the effect before. And as I said, we're moving effects into here, so effects and reducers are essentially the same thing now. But effects are different because they deal with RxJS. And everything else here is signal space. So when load is called, and we need to make a call to the backend to get information, we can't really do that in signals. We have to do that in RxJS, and that's what Rx method does for us. This is saying that load will be a method that takes no arguments, and whenever it is called, we're essentially getting an observable with no value on it, and then we'll pipe on it. So when we get that value, we can switch map on it. And now this is the same as what we saw before. Loader.getList to make the call to the backend, pipe on it to rearrange the data as we need to. Then we don't have a separate effect for handling the error. We can just do it in line here. And when we have our success case, we will tap on it and patch the new task that came in from the backend. So we've put the two different effects together in this Rx method and put it here in a method that can be called anywhere. Now, where is this one called? Remember, loading was done in a lifecycle hook before. It's still done in a lifecycle hook, but it's defined differently. In addition to with state and with methods, we also have with hooks. There's an onInit hook and an onDestroy hook. And this is saying onInit gets the state from which we can get any of the signals or functions that we have. The one we care about is load, so we grab that out with destructuring and recall it. And so when this is initialized, we will call that load that will come up here and switch into an RxJS context and do our RxJS code of the type that used to be done in an effect. Everything else down here is just data manipulation that isn't about NgRx at all. So this is a completely different approach. It's creating a service with a function where we configure it line by line by line, and each line has access to everything that was configured above it, versus having separate actions and reducers and effects, etc. Very different approach. But the upshot of it all is your components don't even know they're dealing with NgRx. They're just dealing with a service that has some sub-signals and methods. So it seems pretty cool to me. To go to the next step, I want to show a more complicated example. So this is another app that we use. This is only used in our NgRx curriculum, not in the standard ABC curriculum, Angular Bootcamp curriculum. And it is a fake blog app that we use. So here we have a fake author, and these are her 10 articles that are built in here. And this is a full CRUD app. We read these. I can create a new one. I can come over here and tweak it. And then delete it. And then also, if we are using the URL bar. So I now have article 3 selected, as you can see up here. If I had bookmarked article 7 and go to that, I'll go directly to that particular article. So a few other concepts going on here. The main thing, besides the router, is that everything in this bit of state is an entity. It's an object with a unique ID, and it's an array of them. So NgRx entities gave us ways to deal with those. We have ways to deal with entities also in signalStore. So I'm going to take a look at here to do a comparison. I'm going to compare step 204, which is currently part of our curriculum, with 207, which may be part of our curriculum in the future as we work on it. And as you can see, there's a lot of things that went away. This was a larger application, so we had actions, effects, reducers, and selectors all as separate files. And now all of those files were replaced with one file. So it's a lot simpler. So I'm going to take a look at the article state file with some of the things that replaced on the left. So as before, we had some selectors, although this selector is interesting because it does some selecting using router store to get the current article ID. And so we have a compound selector that combines information about this bit of state with the route. We have our reducer that uses NgRx entity to build our entities around articles. So we're essentially holding an array of articles, but that gets divided up in separate ways to be stored in the background for user performance. I have a video about NgRx entity that goes into a lot of this detail. I'll give a link later. And then we create an adapter for it that knows explicitly about entities so that our reducers can just say set all, add one, remove one, update one, instead of having to do all of that array manipulation ourselves. And then we have some effects here to load, which again comes from a lifecycle hook, or create, delete, update, all with calls to the backend. All of these things got replaced by article state. So again, we're going to have our signalStore. That is a function that creates this service for us. Now, one thing that is interesting, since this is not a class, in certain contexts, you can't be handled. Like unit tests, if you try to inject it as though you just inject a class, it won't work because it's not a true type. If you really want to have a type of it, you'll need to do something like this. Export type of article store equals instance type of the type of the article store. And this gives you a type that the dependency injection system knows how to use. So that is a step that is not quite obvious, but is helpful to know about. In this case, our store contains a bunch of entities, a bunch of articles. Just like we defined an entity state of article here, we're now defining our entity state of article here. And so within here, automatically what we will get are a signal that has the array of all the entities, an array of all of the IDs, and then entity map itself is an object that is keyed by the ID to have each article in it. So that is the same basic structure that we had in NgRx entity, really good performance. But you're not limited to just that. We could also say with state and pass in, say, name with a default Lance value and import that. And now the state would also have the name signal. We can also have multiple entities. What if we're handling authors directly here as well? That will sort of work, but we'd actually run into name conflicts because we have two different things that are called entities. That's why we're having troubles down there. So we can handle that by giving the unique collections unique names. So now, in addition to our entity map, with this about articles, we also have an author entity map. And we have entities and author entities, and IDs and author IDs, etc. So we have the ability to have multiple entities in all the state that we want all wrapped together. Now, I mentioned the selector, this compound selector. How would we do that? And this is an area that selectStore, our signalStore can't quite do, and I don't know if it will in the future, but it doesn't have an equivalent for RouterStore. It's okay though, because standard NgRx does, and we can still keep it around. We can keep the old NgRx store around just for routing if we want. In our with computed, we're in an injectable context, so I can inject the store and then use selectSignal to get a signal of that current article ID. And once I have that, I can use that in a computed. Similar to how I did that computed of the total, I can now just use that as a signal within my computed. And as far as the rest of the system knows, it has no idea that it got that through standard NgRx's router store. It's just a signal at this point. So here's my computed selector, essentially, computed signal. Current article is computed from the article ID that it got from router store, combined with the entity map, getting that value if the ID actually exists. So it's the same basic thing as this, but over here. And again, we had these special nice utilities for set all, add one. In our with methods, we have basically the same thing here. So we're again combining the reducer and the effects by having the Rx method to concat map on it, make the call to the back end. I have handle error as a method here that just does the catch error just to be convenient. And then tap on it to patch the state as the result of these calls to the entities. These come from signalStore as utilities. So it makes our life easier. So that is how this application was adapted. And then components got adapted because now instead of getting observables, they're getting signals. And so there's other processing that's necessary for that. But those components don't know that NgRx is involved. All they know is that there's signals. And that's just observable to signal conversion. Has nothing to do with NgRx at this point. So overall with signalStore, it's a new mental model. It's a different way of doing things. It's not Redux. But it's much simpler for our components because we're really just dealing with a service at this point. And it's early days of this library, but I think it has a bright future. There are potentially some missing features. It doesn't have router store, but as I said, you can use the traditional NgRx as router store, so it doesn't really seem to be a problem. Maybe they'll port it, I don't know. It doesn't have meta reducers, which were special reducers that were registered at the root that had access to all of the traditional NgRx's store or state. We don't have that because these are just independent services. There's nothing that contains everything. So that's missing, but meta reducers weren't used a lot, so I don't know if that's a problem. And some people are really concerned that dev tools don't work with signals. It's the time-traveling debugger that you can add as an extension in Chrome. But it was recently announced that there's a community effort to create it as a third-party library. So we'll see where that goes. And for me at least, I'm still learning the unit testing patterns to figure out how exactly to inject these new types of stores and how to write my tests around signals instead of observables. But the community will get there. So I think it's overall a good change. I don't know what's going to win. I don't know if people are going to love signalStore and get rid of old NgRx or if they're going to live side by side. No one knows yet. It's too early, but we'll see. But I hope that this has been a good lesson and a good primer for you on how signalStore will affect your apps. Thank you to Marko Stanimirovic, who's a new member of the NgRx team, who was the main driving force for this, and Manfred Steyer, who wrote up a lot of documentation and examples that I used to help me understand this. Some of the code that you've seen today has been published at the GitHub there for Angular Bootcamp. Some of it is also just pre-release. Maybe it'll be there eventually, but it's not there yet. I also have links to 2 videos, one I released last week about the Angular Renaissance and signals, and an older one about NgRx entity. The slides are available through the QR code or that link on the right, and at the bottom is my information. And if you liked this talk and want to learn more about NgRx or Angular in general, please come visit us at angularbootcamp.com. We'd be happy to set up a class. Thank you.